Alright, in the last video I was starting to talk about the moons of Pluto, and how we knew about Charon for quite a while. And let's see here, when do we, I think 2005, I didn't memorize it, I looked it up when I was researching the latest, greatest info and data we collected on New Horizons. Was it Styx? No, it's probably one of the bigger ones. Those would be easier to discover earlier. So it's probably one of these two discovered in 2005, and I'm guessing Styx and Kerberos were most recently discovered just a couple of years ago. Actually, let me pause, and for those of you who are curious about dates, I'll get that right. Yeah, so Nix and Hydra were discovered in 2005, very recently, but even more recently, Kerberos in 2011, and 4 years ago, Styx in 2012. So, um, didn't know about these for very long. We haven't known about them for very long, so 'cause they're tiny. And so, what are some characteristics of Pluto that I didn't talk about before? Again, some of these we've known a bit for a while, based off of just knowing how things work, like how light diminishes as distance increases, etc. But other things, New Horizons either fine-tuned our measurements or found completely new, previously unknown data. Pluto is very far away. Light, which travels very quickly, at least on our size scale, length scale, takes over 5 hours to reach Pluto. Now, Pluto has a very eccentric orbit, if you remember from the 2 years ago video I recorded. Very eccentric, and it's also not aligned with the plane of the solar system. I don't think I mentioned this 2 years ago, but I think it's pretty curious, pretty interesting how Pluto was closest to the Sun back in 1999. Now it's hard to tell from this picture because it looks like it's farther than Neptune, but it's because the orbit's so inclined, it's sort of hard to represent it three-dimensionally. But this would be the closest approach to the Sun, 1999, and ever since then, wait a second, yeah, ever since then, it's been, wait, yeah, I take that back. We're going to shift up this way a little bit. So, and actually, it sort of, the picture's not as confusing as I thought, and I was just confusing myself. But from here to here is where Pluto is closer to the Sun in its orbit than Neptune, and the rest of the time it's farther away. So actually it was 1989, where Pluto was the closest to the Sun, and ever since then it's been getting farther and farther away, which leads to some interesting changes. And then in 1979 and 1999, those are the points where Pluto first became closer to the Sun than Neptune, and first became farther away. In other words, it sort of intersected Neptune's orbit in these 10-year intervals, so 79, 89, 99. Anyway, sort of forgot what I was talking about. Oh yeah, Pluto is really far away, and when it's closest to the Sun, again, it's a very elliptical orbit, so when it's closest, it will take less time, obviously, for the sunlight to reach Pluto, and when it's farthest, it'll take more time. But on average, it takes about 5 hours or so for light to travel all the way from the Sun to Pluto. So it's really far away. And that also goes for any data that we're getting from New Horizons, or any commands we send to New Horizons. Those travel at the speed of light, because radio waves are light. They're still electromagnetic radiation, just at a different wavelength than visible light, and that travels at the speed of light out, so it takes quite a while for us to get data from New Horizons or to send a command out. Other orbital things that I didn't talk about, it takes 248 years for Pluto to go around the Sun once, so we won't see another closest approach like we did in '89 for another 200 plus years. It's a very large orbit. It takes a long time to go around. And its day is pretty long too. Its day is almost 6.5 Earth days to spin around once. So that leads to some interesting seasonal things and daily patterns and whatnot. Plus, the incline of its rotation is pretty large too. So that gives it some really strange seasons. But I'm not going to go into that. So because Pluto's so far away, the sun is not that bright. The star, when you look up in the night sky, of course you don't see many stars where we live because of so much light pollution. But if you go out into a very nice dark area, you'll see lots of stars. Our sun could be any of those, although most of those stars are actually much brighter and bigger and brighter than our star. Our star is actually a pretty average, not super bright star, which is a good thing for us. But the farther away you get from any object, the dimmer it looks because the light spreads out. So when you're way out at Pluto, the sun is also not that bright. Definitely, it's much brighter than any star you would see, but way dimmer than the sun appears on Earth. How might you get a good idea of how dark it is on Pluto or how bright it gets? Well, wait a few minutes after sunset or a few minutes before sunrise, and that's sort of what it would look like, although the atmosphere changes things. Light's scattered in the Earth's atmosphere, so that might make it a bit brighter than it would be on Venus as well, or appear brighter anyway. And you would also be so far away from the sun on Pluto that it would almost be like a point, like a star. If you get solar eclipse shades, you can't look directly at the sun without hurting yourself. But if you get solar eclipse shades and look at the sun from Earth, from our planet, the sun's pretty big. You can see a pretty big circle. In fact, it's just as big as the moon is. That's why an eclipse works the way it does. But again, the farther away you get from an object, the smaller it appears, until the point where it will look like a point, like all the stars that we see in the sky. Same thing would be for Pluto. It's so far away that you can't really see any size or very much at all for the sun, but it would still be way brighter than any normal star normal typo fixed any normal star you have ever seen. And there's a website called Pluto Time. If you're bored one day and you want to see what Pluto might look like from where you live, just go to Pluto Time. Pluto Time just search Google like NASA Pluto Time and type in your location. We're here, Silver Spring. So after sunset on January 3rd, that's today, at 5:02 p.m., which is in 42 minutes from when I'm recording this. That's about how bright Pluto will look. Keep in mind again, though, that the Earth's atmosphere being different than Pluto's would affect things a bit. Yeah, and what about the surface of Pluto? Well, now that we can actually determine what the surface is composed of, because we got really close with New Horizons, and you can see all these pretty pictures. This is not a real picture, a true color picture. I think this picture I put here is pretty close to true color. So it's very orangey in a lot of sense. This picture is false color, and scientists do that a lot to sort of bring out the different materials, the different compositional materials on a solar system object or any other object. And so you can see, or it has been determined, that most of the surface is composed of nitrogen ice. Very cold out there, so nitrogen can be in ice form. 98% of the surface is that. A small trace percent would be methane ice and carbon monoxide ice. So the colors, although this is false colors, you can't really tell that, but the colors can range from charcoal black, dark orange, to white, and the really icy bright parts. Um, Based on what we've seen so far from New Horizons data, all this data again is still coming in, so this is going to be, a lot of what I'm talking about is going to be fine-tuned over the next couple of years. So, you know, keep that in mind. Take what I'm telling you with a grain of salt, because that's how science works. The more data you get, the more clear a picture you can paint of something, and so things will be rapidly evolving in terms of what we know about Pluto. But anyway, it appears at this moment that Pluto is very geologically active, which came to a surprise to a lot of people because it's so cold and so small. You'd think it would have cooled off by now and lost a lot of its geological activity, but it appears to not be the case, which is very interesting. So we'll find out more about that in the coming year or so. Size-wise, it's again pretty small. It's even smaller than our moon. But here, get this. It while being slightly larger in diameter than another Kuiper Belt object called Eris. Um, so the diameter of Pluto, by the way, has fluctuated a bit over the years, but this is quite accurate. This is from New Horizons data. We've never been so close to Eris, so it's still in that inaccurate phase, but it appears that it's slightly smaller. Eris is slightly smaller than Pluto by, a good 10, 20, 30 or so kilometers in diameter, which is not much. They're about essentially the same size. But Eris is more massive than Pluto. So you might ask yourself, all right, well, if Pluto should still be determined to be a planet, what about Eris? Why wouldn't Eris be a planet? It's the same size-ish. It's even more massive, actually. So maybe we should add more planets instead of taking planets away. But when you classify things, the more generally you classify, the more you sort of take away from the specific characteristics. So there's nothing wrong with creating more in my opinion, this is opinion, with creating more subclasses per se, or more specific classifications, and based off of characteristics. If you want to get a little more specific, why not call these type of objects something different, like ice dwarfs? But anyway, that's my opinion. There's a lot of debate about that right now. But Pluto is small. It's only 17 or maybe closer to 18% of the mass of our moon, meaning it's not very dense. It's only a quarter of a percent of the mass of the Earth. So it's actually a pretty tiny object. That's one of the reasons why we couldn't really capture New Horizons as it flew by. And atmosphere composition, very similar to the surface composition, which isn't really that much of a surprise because a lot of what's in the atmosphere actually freezes down on the surface when Pluto gets far enough away that it's too cold for these materials to be in gas form. But a lot of nitrogen gas, a lot of methane gas, a lot of carbon monoxide gas, probably in similar proportions, where most of it is nitrogen and more trace amounts of methane and carbon monoxide. And I already talked about this part, about the gases freezing down onto, oh my gosh, nothing there is onto the surface. And methane, being a very powerful greenhouse gas, actually affects the temperature variations on Pluto in terms of the atmosphere compared to the surface. And I think I'll be able to finish. So, in conclusion, get a little philosophical on you here. We still have a majority of the data yet to be sent. So one of the trade-offs in making this mission possible was to send it out quickly, make the spacecraft as light as possible so that we could, get it really moving really fast. And so one of the trade-offs was we weren't going to be able to rush and send the data in large chunks. We're sending it like a little drop at a time. Doop, doop. It's like trying to fill up a tea kettle with drips of water. You're going to be waiting like an hour to get your tea because, But anyway, you get it eventually. So data is trickling in, and what we know now is going to be definitely evolving over the next couple of years. as more of the pieces of the puzzle come in. But that's how science works, right? Just be patient, gather data little by little, and eventually we gain a deeper and deeper understanding of our universe. So that's the last of the outer solar system objects I'll be talking about. And keep Pluto in mind in the next couple of years. Keep looking in the news for new theories on what makes Pluto tick. And maybe someday in the next couple hundred years we'll go visit it. SpaceX might be there. Anyway, take care, guys. Bye.